In this episode of Database School, you are going to hear me, Aaron Francis, talk to my friend Glauber Costa. He is the CEO of Turso, and they are embarking on an ambitious full rewrite of SQLite from scratch. So, of course, we talk about the reasoning and the rationale behind it, and then we talk a lot about the deterministic simulation testing that they're doing. We talk a lot about the contributors and the open contribution model and everything that is going into this full rewrite of SQLite. It's very interesting. I highly encourage you check this one out. Also, if you have anyone you want to hear on the show, let me know. I love having people on the show. This is a delight for me, so please reach out. Let me know who I should have on next. If you want audio, there's audio. If you want video, there's video. You can find everything at databaseschool.com. All right, that's enough for me. Let's get to the show. Hey, y'all. Welcome back to Database School. I am here again with Glauber Costa, the CEO of Turso. Glauber, do you want to introduce yourself?
Aaron, thank you so much for having me. It's a pleasure. I think it's my second time here chatting with you. And it's always a pleasure to talk about the things that we are doing. I'm Glauber Costa, as you mentioned. I've been in the industry for a long time. I remember when I was a young guy full of hair. Most of that changed now. Some of it in very radical ways. But I spent the first 10 years of my career working in the Linux kernel, the vast majority of that time on behalf of Red Hat. That's where I met my today co-founder, Pekka. So all in all, I've done that around 10 years, and then I joined a company that had a product that didn't quite succeed, but then they pivoted into a database. In the NoSQL market called Scylla. They're still around. They're still very successful in the niche that they cater to. And then after another decade doing that, they had a very brief stint at Datadog for a year, where I learned a lot about many things in the big tech world. And then we founded this company, and we are now rewriting SQLite from scratch, which I guess is what we're going to be talking about today, right?
Yeah, that's absolutely what we're going to be talking about, because just on the face of it, it sounds crazy, and I know a lot of the reasons you're doing it, and they're not crazy, and so we're gonna have to square that circle. But before we do, not only are we internet friends, colleagues, sometimes coworkers, we are now neighbors.
We're neighbors.
Are now a Texan. You moved to Dallas, so just tell us quickly. We'll talk a lot about SQLite, but we live like 15 minutes apart, and we're still doing this remotely for reasons I'll explain later. But tell us.
Can I call myself a Texan, Aaron? I just arrived.
Of course you can. Yes.
I'm very excited to be here. I still have to police myself and make sure that I'm saying y'all all the time, which is I haven't picked up yet. So feel free to correct me when I fail to do so. Texas is very hot. I'm coming from Canada. And the past 5 years, I was in a very small town. I moved there with COVID from Toronto. I was in a very small town called London, where the winters are way more brutal than Toronto. And it would get routinely to minus 20, minus 25, sometimes a little bit more than that, or a little bit less than that, right? And man, Texas is hot. I mean, I knew it, but it's knowing, and it's if you watch The Matrix, like knowing the path and walking the path, two different things. But look, everybody was calling me crazy. Everybody was calling me crazy for rewriting SQLite, and I did not want that to be the craziest thing going on in my life. I said there has to be something crazier going on in my life. So I moved to Texas with at the time 8-month pregnant wife. And as you know, like the baby is threatening to come for a while with 3 kids. And because of the very draconian Canadian exit tax system that taxed me on my capital gains, of unrealized gains, including my VC-backed company, I left most of my money behind to pay those taxes. So this is, rewriting SQLite is not the craziest thing
Yeah.
I'm doing. And so moving to Texas itself, it's fine. I mean, it's all the situation around it.
Yeah.
The pregnant wife without an OBGYN that she had to go look for, and the other three kids and looking up for school and all of that. Gladly. And we had help. So thank you. I mean, we had you helping us in a lot of those pretty tough situations we got ourselves into. So it's all going good.
Good. Well, I'm glad you're here, and
Yeah,
that was a smart PR move to do something even
even
crazier, which
crazier.
is move to Texas in the summer with
In
a
the
pregnant
summer,
wife
there you
and
go.
three
Yeah,
kids, and pay Canada
yeah.
for the privilege of
That's
leaving.
off
So
leading. There you go.
that does make rewriting SQLite look pretty benign. So talk to us before we get into the full rewrite. Explain just a brief history of Turso, because Turso is the name of the company. So
Yes.
we're gonna throw out a lot of words here. We're gonna throw out SQLite, libSQL, Turso Cloud. So tell us up until maybe just like a few weeks ago, what was the name Turso, and we'll talk about what the name Turso
Yeah.
is going to become. But explain the company briefly.
Yeah, so we started this company and we had a couple of months in which we were doing something else altogether, using SQLite. We were users of SQLite. Pekka and I, we are. In fact, I was talking about it on Twitter the other day, X, that I still remember where I was the first time I used SQLite. So magical it was, and the year it was 2004. I remember where I was sitting. I remember in which side of the room I was sitting. I
That's
remember
crazy.
which computer I was using. I don't remember what exactly I was working on, but I remember like having this file that I just typed SQLite 3 and it's a SQL, it's a full SQL database. I mean, that was like 21 years ago, right? Just 2004. It's older than I guess a lot of people in your audience today. And so I always loved SQLite. I was always a fan of SQLite. I'm a huge fan of simplicity, which SQLite is the embodiment of, right? So we were using SQLite in our product that we were building, and we pivoted away from that idea because we were starting to notice that SQLite is great, but it could be even greater. And again, for context, Pekka and I, Pekka being my co-founder, we spent each one of us around 10 years working in the Linux kernel. So we are very comfortable with C. We are very comfortable with low-level code. We also wrote a database. I actually wrote another database when I was a Datadog. So we're very comfortable with the space. And we figured, hey, look, I mean, we can SQLite is amazing, but it could be pushed in certain directions that we believe the industry today is going, and it will be even better. So and we also realized that specifically the things that we wanted to do at the time were not technically very complicated. But the problem is that you make those changes fine, and then what do you do? And again, we've been doing open source for all of our lives. And what do you do is that you send this code back to the project. This code now becomes part of the project, and then you go from there. But you can't do this with SQLite, right?
Nope.
SQLite is a lot of people do not know this, but they are a closed community of they don't accept contribution. The code is open. It's technically not open source. It's public domain, but I'm going to let the lawyer, for me, it's all the same. I mean, I'm going to let the lawyers discuss the differences. I do not care. But it's a closed community because no code can make it into the main project. The best you can do is convince the maintainers of SQLite to do it for you. And again, of course, they are only three people, and they have competing interests from a large group of people. And we figure, hey, look, I mean, SQLite doesn't have a technical problem. SQLite has a social problem in that sense, because I mean, the way the community is structured does not lend itself to a database that can grow in scope. Now, a lot of people view this as a good thing. I disagree, and again, my disagreement comes from the fact that we work together. So there's this thinking that if you make things big, they will necessarily become sloppy, and if you make something open contribution, if you open the gates, things will necessarily become bad. And I understand where people are coming from because that is usually what happens. So I'm not disputing that this is a correlation does not exist. But Pekka and I have this example of Linux in which things work very successfully. Linux started as a toy project from Linus Torvalds. Famously, he says in his first message that he sent about Linux, this is a toy. This is never going to grow beyond the scope of a toy. It only works on x86. It's not architected to work in anything else. And today, Linux runs the world. It runs in every single processor that still matters. It runs everywhere, from supercomputers to small devices, and it powers the world. So we believe it's possible. I mean, it's not. I'll grant that. I mean, it's not to be taken for granted, and it's not automatic that things are not going to turn into a big ball of slop. But it's possible. So we figure, why can't we have something that is open contribution? And we're not saying, and this is something that some people understand, that are you saying that they're wrong in doing this? I mean, I don't believe too much in right and wrong in this context. I mean, they have the right to do what they do, but we figure the usual open source saying is, if you don't like it, fork it, and that's what we did. So at the time, we wanted to rewrite SQLite. What we thought at the time is that, hey man, SQLite is amazing. It's probably, it could be more. I mean, imagine SQLite with this open contribution community. Imagine SQLite being what it is today, but with 30 people consistently contributing to it. How amazing would that be? And we wanted to rewrite it, but we decided not to. And to keep it simple, let's just say we decided not to because of reasons. Some of those reasons maybe were wrong. Some of those reasons maybe were right. But we decided we will fork SQLite instead, right? So instead of rewriting it, we would fork it, and that's how the libSQL project was born. And Turso, then the company, was born out of that. So Turso at the time, now with this context, answering your questions very directly, Turso at the time was a way for you to use SQLite as a serverless database on the cloud. And so we built a server around it, which was part of the libSQL project. You could send HTTP requests with your SQL statements to it, and we would respond. And this would fix, in our view, one of the areas in which SQLite wasn't that great, which is serverless, right? And why? Because SQLite is just a file, so if you want to use it in serverless environments, you can't. So when you start with your project, that's all fine. But if you happen to pick a serverless provider, then you have to abandon SQLite. So we figure we're going to start here. And over time, our ambition was always to push the libSQL project in more ways than one, in directions. So the way we framed libSQL, the project, was this is the open contribution fork of SQLite, where everybody's welcome to come and contribute. One of the ways in which we are contributing to this fork is by adding the hooks at the right places to allow us to use this over the network. So it was beautiful. You could develop locally in a SQLite file, but then if you want to push this to serverless, you would just change the URL. And now you have the same database on the other side that you're now accessing over the wire. So that was Turso for the longest time. We did make other contributions to the libSQL project. So in line with our original intent, in line with our original goal of making libSQL just like this open contribution fork of SQLite that will just expand and be things that SQLite cannot, we added native vector search, for example. So you could do your RAG workflows, and you wouldn't need an extension. It was integrated with the language. It was not something that you had to boat in, and we added vector search. And so if you go back to that, if you had a fork of SQLite that 80% of what it did was allow it to be competently used over the network when needed, and still retain, of course, the local the ability to run it locally. And then he had vector search, and that was 99% of what the libSQL project had. It had some other things. I mean, we had one attempt that we had in making schema changes a little bit better, but and that's going to become the story. And I'll stop there to let you go into why that. But to give you the hook, vector search on libSQL is amazing, but not perfect. And the schema changes, the way in which we improved schema changes in libSQL is good, because schema changes is one of the things that people are always complaining about SQLite, but it's not perfect. And the way we use SQLite over the wire is also good, because it allows us, and that's the business that we still have. But it's also not perfect, because there's a couple of things holding you back in doing that, and that's where the rewrite came from. Right?
Okay, so from what I'm hearing, it sounds like in terms of open source or like for a project, using a project, there's kind of a continuum. On one side, there is just use the project as it exists, which would be SQLite. Then there's let's contribute to that project, which in this case is just not possible. So
it's not possible.
they've been very adamant about. This is, and I agree, it's open source. I don't know, the technical difference. This is open source, but it's not open contribution. And neither of us are making a judgment call on that decision, but it does make it difficult for outsiders to have any influence in the project, which again is probably what the maintainers want. They don't want outsiders to have influence.
And they have the right to do so. I mean,
they do.
Fine.
Yeah, that's the beauty of I think DHH says open source is a gift. You can take it or leave it. You don't get to dictate. And that has led, at least in my opinion, that has led SQLite to be rock solid. That's one of the things that the community, the industry at large, likes about SQLite. Of course, it's fundamentally different than most other databases in that it is embedded. It is a single file, but it's also incredibly stable. They've been working on it for 30 years, and they've tested every potential failure. So you're at this point where the next step in the continuum is let's contribute to it. Not possible. So the next step would be let's fork it. Let's fork it. Let's try to keep it up to date with upstream, but add a bunch of stuff. And should they ever want to pull stuff in, we are so happy to give it back to them. That was publicly stated in your libSQL blog post. Hey, if y'all ever want this, we are ready to give these contributions back, but it's not on the table right now. Then at the very far end of the continuum is let's rewrite it from scratch, which is where we're about to go. But just to paint the picture of all the terms. So you and Pekka and the team have libSQL. It is a fork of SQLite. Turso, the company, as it exists up until just maybe a few minutes ago, is the name for the cloud, the hosting thing. So that's all up until the present moment. Now, at the present moment, we're going a step further and we're doing something crazy, which is fully rewriting SQLite from scratch. Instead of just maintaining a fork, we're rewriting it from scratch. And so let's talk about the decision to do that, because the last thing you said was libSQL is good at this part but not great. It's good at this part but not great. And you said that 3 times. And so
that's right.
What is the limiting factor or the limiting reagent that makes the fork unable to reach greatness, where the rewrite is presumably going to reach that level that you're hoping for?
That's right. And then just to fully clarify the terms, talking about the past is always like that, because hindsight is 2020. But we decided to keep the name separate, which we thought it was a mistake. We learned it was a mistake. So libSQL and Turso existed as 2 different things. And one of the things that sometimes you're going to hear in the startup world is that it is very hard for a startup to build a brand, let alone 2. So we ended up with a very confusing situation. And again, we were not ignorant to any of those things. We just weighed it against other things and said, so because I would have no shame in admitting, by the way, that I wasn't aware of that, or I didn't hear the advice, etc. But the reality is that we just weighted it against other things. And specifically the thing, just to put it on the table, is that, again, our main goal is how do we didn't want to have a fork of SQLite. We wanted to have the open contribution fork of SQLite. So our fear was that if we have the same brand as the company brand, some contributors may feel discouraged to contribute and say, am I contributing to this company?
Sure.
And the way open source was, I think 20, 30 years ago, this would have been a factor. So we decided to keep things very separate, and this is libSQL and this is Turso. And what we learn over time is that for whatever reason, this just doesn't matter. Like it wasn't a thing. So we ended up with the burden of building two brands, but without the fear that we had that people would feel awash and not coming just wasn't there. And I think it's just a matter of like how open source evolved in the past 20, 30 years. And also a matter that like in all the things that you can do to push contributors away, this is probably less than the least, right? So maybe it does help you like by 1% or 2%, like having a community that is actually helping people and merging their contributions. And if I want to build a competing business to yours, here's can I do that? And we say, sure. Like that is probably better and more important than the name, right? So when we decided to rewrite, it was clear to us that, okay, since we are in a sense restarting this project, let's do it right. And let's call it Turso. Now, we didn't call it Turso initially because it started as an experiment. It wasn't something that we were taking seriously, and we can go into that too. But the moment it became clear to us that there's so much potential here, and this is going to work, we're very convinced that this is going to work. We decided we were going to rename it, and then we just for practical reasons, so we're not going to rename it now. We're going to rename it in the future. So we were very explicit about that. We put it in the README that this was going to be renamed. And then we started making moves towards making this renaming smooth and not confusing. But we are now at the point in which this rename came. So now the rewrite of SQLite that we are doing is called Turso, right? So this company now is all about evolving SQLite. And we still have the cloud product. The cloud product is there. I think the cloud product will evolve in interesting ways that we wouldn't before if we were not rewriting. And this rewrite is now called Turso Cloud. Now, it's still a little bit confusing for a little bit longer because the Turso Cloud does not run Turso, right? Because Turso is not production ready yet. The Turso Cloud runs SQLite, right? But this is going to be with us for a little bit longer. But if you fast forward now, at least it's clear that Turso is an embedded database. There is a product called Turso Cloud that is compatible with SQLite. You can use SQLite databases on the Turso Cloud, and then you fast forward another year. There's no more confusion because there is the Turso database, and then you can use those Turso databases which are compatible with SQLite in the Turso Cloud. So it's just us moving right in the direction of reducing that confusion. But every time I'm talking about the cloud product now, the serverless database, the serverless SQLite, we're talking about the Turso Cloud. And when I'm talking about Turso, that's the rewrite of SQLite. Right?
Okay. Yes, that's very helpful. And it sounds just like growing pains. That just seems very normal to me.
And there are many ways to solve it, and some of them are more disruptive than others. And like that's the way we solved it was a way which we believe was the smoothest, and that's what we went with that. Right?
Yeah, I like the decision to rename or name the rewrite Turso because there was always, it was a nice separation of libSQL and Turso, but that created confusion. I mean, that just obviously was like, wait, I'm using what now?
Yeah.
So you're at this point where you've pushed libSQL potentially as far as it can go, and Pekka starts working on Limbo, which is just like experiment. It's named Limbo presumably because it's in between. We don't know if it's going to work. We'll try it out. We'll see what happens. Limbo is now, let's forget that name, listeners. Don't worry about the name Limbo. Limbo is now Turso. Turso, the embedded database, which is a ground up rewrite of SQLite, which they always tell you not to do. So talk to us about kind of the decision. So it started out as a little like experiment, but then when did you reach that inflection point of, okay, we have to do this?
Yeah. So the as I said, we had this idea to begin with. Let's rewrite SQLite. we decided not to do it, and I think one of the reasons we decided not to do it was that we wanted to keep things working from the start, and we wanted to be very compatible with SQLite. And but going back, those are all things we knew. It's just that we weighted things differently. And to your point, in your question, like what was the limiting factor for libSQL? SQLite's test suite is proprietary, which is something that a lot of people do not know. If you download the SQLite source code, there are some tests in there, of course. I mean, there's some very basic unit testing, but a lot of people talk about the fact that SQLite is this amazing, piece of technology in the industry, very different from everything else, because there are 5 times more lines of code in the SQLite test suite than in SQLite itself. So SQLite is a testing project. If you think about this ratio, but that famous test suite that is 5 times bigger than the source code itself is not open source. It is proprietary. And what that means is that it is very hard to make deep changes to SQLite, even as the fork. So, and again, we knew that, but we figured there will be other things that will make the decision to fork still be worth it. And I think part of that is that we thought that SQLite will be, and this was ignorance on our part. We thought that maybe things could be more modularized than in practice they really could. I mean, I think we underestimated the amount of work we could do in the margins. In our idea, like, yeah, we can make this tiny change to the core, and then with that tiny change, we're going to make this pluggable, and then which is one of the things we did with libSQL, by the way, just to get concrete. And we were successful at that in libSQL, which is why we thought we're going to be able to do this with all features. We wanted to do replication. For in the cloud, you need things like that, and we wanted to do wall-based replication. Now, the wall in SQLite is the most recent changes, the write-ahead log. So what we've done is that we made very tiny changes to SQLite to allow the wall to be virtualized, and then you essentially allow the wall to be replaced by your own implementation. So we never changed the SQLite wall. We made changes that allowed the wall to be replaced by a different implementation. And then we had that entire implementation separate, done in Rust, and very well tested, right? So that's how we figure, like, we're going to be able to keep doing this. So the fork is still the best way to go, because yes, SQLite is, we're not going to be able to do very deep changes, but we can go very far without making those deep changes, because we can use these strategies. And again, maybe they wouldn't be how you would otherwise do if you have a blank canvas, but it's fine and it's going to work. Vector search was already not like that. So to add vector types to SQLite, it was very, 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 very hard, and we had to make very deep changes. And even then, it was over a certain point we were not willing to do. So if you use, for example, vector search in libSQL and on the Turso Cloud, because we deploy those libSQL databases to the Turso Cloud, you will see that it's very integrated with the syntax. You can use vector columns together with other columns, and you just add a type, and then you can do search. You can do queries that mix and match normal SQL with vector. It's beautiful. But whenever you use an index, then you have to explicitly write a join with an external table, and all of that, because we felt comfortable pushing the changes to the core, to the grammar, because it's easier to test in isolation. But we were not very comfortable pushing those changes to the index lookup in the query planner, because that is much, much deeper, right?
It's pretty gnarly.
So you end up, and we could not replace it either, because then you go into the bytecode and the code generation and all of that. So you get, similar things happen to schema changes, right? And we got into a point in which our schema changes in libSQL are better than SQLite, but they're not revolutionary better, because to do them well, you would have to go patch things that are very core. And SQLite in the cloud, the main problem that most of our customers have is that if the use case fits what we are good for, fantastic. And we tell people what we're good for, right? But a lot of people try to write a lot to SQLite, or maybe they don't think about it in advance, and then the workload just grows and whatnot, and you end up writing a lot. And one of the things SQLite is not very good for is writing a lot. And in the cloud, because you have the network time added to that, you hit the ceiling of what you can write to much faster than you can write. And again, fixing the SQLite write throughput problem is it's not something that you're going to do just by replacing a couple of things here and there. And then we had the partner. There's a very big company that unfortunately I'm not allowed to. I'm working with them to try to allow them to tell them who they are. But like they wanted to do column level encryption in SQLite, and then Pekka and I just said, look, man, it can't work like that. And what do we do? And there were, of course, many paths of like, don't do any of that and try to focus. And there's a huge market, especially now with vibe coding and AI agents. Lots of those use cases are coming to the Turso Cloud because we can offer people like unlimited databases. So every prompt of yours can have its own database. There's a huge market to be pursued with SQLite as is. But man, what if, man? What if we were to rewrite it? Like, and that's how this idea started coming in our minds. And Pekka wanted to do it, and I was like, yeah, maybe it's not, maybe it's not the best business idea. It's probably the best. We were convinced by then that the judgment call that we made wasn't terrible. The forking of SQLite was something that was very well received, but maybe rewriting would have been better. Challenges with that too, but like maybe it would have been better. Who knows? And we were living in this what if scenario. Until Pekka decided to do it. I mean, that's what I love about him. Even though I told him it was probably not the smartest, idea, not from the technical point of view, but he decided to do it. We didn't want to associate the company with that because, again, it was a very experimental thing. Mm-hmm. So he just did it on his GitHub account. We never talked about it. Turso never talked about it. I never talked about it on X. Pekka a couple of times just mentioned I'm doing this. It was on his own GitHub account, and he just did it. And he did very little. He did very, very, very little. What he did is that he wrote a spreadsheet with all the features of SQLite. That is a file that's now in the Turso repository. This actually, by the way, was one of the reasons this project succeeded. Sometimes we talk about the technical reasons and we go about all of the, but one of the reasons I think the project succeeded is that Pekka came up with this matrix of features. It's a very long matrix of every single thing that SQLite supports, down to the individual opcodes of the bytecode generated, like this opcode, that opcode, this other opcode, everything that SQLite does, every function, every opcode, every language feature. It's in a file called compat.md. And then he just said, is this supported by the project that was then called Limbo? No. And then he started doing one by one. The first one was select without where clauses, without anything. All you could do is select one, right? And then you flip the compat matrix to yes. And then he decided to just do it in the open in his own GitHub account. And he did it for around 3 months, if I'm not mistaken, something like that. And again, he had many other things to do. It was just like, sometimes if my kids are sleeping, I'm going to go hack on this. And after 3 or 4 months, now very explicitly going to your question, when did you notice this was going to be a success? We had an early sign. And what was this early sign? After 3 or 4 months of Pekka just doing this on his GitHub account, without talking about it, without mentioning this anywhere, without any backing, right? Without anything. This got you 1,000 GitHub stars, which is what a lot of open source projects never get you. Which is a very cheap metric, but now's the real metric. libSQL at the time, and remember, we want to create, that was our goal. We wanted to create the open contribution because we always thought, if it was hard for us to make changes to libSQL in the core, imagine how hard it was for external contributors. It was very, very, very hard. So we had contributors to the libSQL project, but most of them were contributing very simple things, They were contributing to the drivers, which were part of the project, like the language bindings, and not a demerit to those things, but we never managed to create a community of people doing hardcore database stuff, which is what we believe. If that happens, imagine what we can unlock. So imagine this: 3 or 4 months, give or take, of Pekka doing this on his as a side project on his GitHub account. 30 people contributing to this project. 30. libSQL at the time had around 100 contributors. This toy thing that Pekka was doing, on his GitHub account, 30. What does it support? It supports select and a couple of functions. And who are those contributors? So we have a lot of people, as I said, that were coming to libSQL. Most of them doing simple things. The people coming to the rewrite, they were doing complex things. So complex that we decided to hire 2 of them to work on our server, because they proved, it was very obvious through their contributions that they were very, very, very good people, right? Like top notch in the industry, like people that can hold water to anybody there's ever seen. I mean, one of them was actually working in the SAP team at Red Hat, like, very relevant stuff. The other person was actually not, he was just having a random backend job somewhere, but like a fantastic database internals guys. And this was a signal that we didn't have with libSQL, right? And then what we decided to do in December the 16th, 2024, was only this. We're going to do no extra work on this. And by the way, after we hired those people, they actually would decrease their contributions to the project because they were super busy, right? Just doing the other stuff on our server. And we decided to graduate this project from Pekka's personal pet project to a Turso pet project. It was still like, hey, we were very clear when we wrote the blog. There was a blog about it that you can link it if you want. In December, around that time, said, don't read too much about it. Don't read too much into it. This is just an experiment. If it works, maybe in the future we can get some people working on it. And it was just like, this is something cool that we're doing. This is we were very clear about that. This is just something we're experimenting with. And I think part of us just wanted to see what happened. And we also had this idea, okay, we're getting so many good people that maybe we're going to use this as a way to get other great people. And who knows? I mean, in 6 months, in a year, maybe we can take this more seriously. But we never had this intention at the time of because it sounded crazy. Let's just go all into this, right? Because we have a company to run. We have the roadmap on the Turso serverless cloud and however you call it at the time. But then we move it from Pekka's GitHub account to our corporate GitHub account. I tweet about it. Pekka tweets about it. And then in 3 weeks, this thing jumps from 1,000 GitHub stars to 8,000 GitHub stars.
Wow.
And from 30 contributors to 64 contributors. And this is the signal I care about because, again, our bet is that SQLite could be better if it had a community of contributors, which it lacks, and we managed to maintain the high barrier to entry that keeps SQLite being the rock solid piece of. So we were saying, if we can do this and this and this, then we'll be able to do something meaningful. And going from 30 contributors to 64 contributors, and obviously a lot of those are people who came and contributed something and went away, but many others came and stayed, right? So from this jump from 34 to 64, we have at least 5 people who are still there today, right? Today, 6 months later. It was just a signal we could not ignore. We said, look, and it was just like, in our minds, it became clear that the industry agrees with us that there is a need for SQLite to be more, that our experience was validated, like all of those things that we want. But the requirement to do this was it has to be something that we can contribute to at the core level. It can't be something that we can only patch only patch the boundaries. Even for people coming from the outside to buy into it, it had to be something that gave them the boldness, the courage, and the tools to make deep changes and to make this without the fear of like, the best will be to go this way, but we can't go this way because if we make that, we're not going to be able to test this, right? So it became clear that for us to realize our vision, we had to do this from the scratch. And once more, in 3 weeks, we saw this from 1,000 GitHub stars to 8,000, from 30 contributors to 64 contributors. And then we all went in for holidays. And when we came back from holidays, we decided that we're going to restructure the whole company in a way that allows us. And what that means is that we killed the roadmap for the cloud. We had the 1 year roadmap in the cloud. We said we're not going to do any of that. And by the way, we were because a lot of companies, I think, I'm very proud of that fact. I think a lot of companies would have done this in a treacherous almost way in which you're trying to fool keep things going and like try to make the appearances of that the things are going in a certain direction while on the side working on the real roadmap. We did not want to do this. We pride ourselves very much on being very transparent with our community. So we released a blog post in which say, hey, this is what's going to happen. This is what it means for the Turso Cloud. This is what, we're still going to support it. We're still going to be put effort into that. So we're not going to kill the product. We're going to be fixing bugs. We're going to be improving it. But this feature, this other feature is gone. We're not going to be working on it anymore, right? So for example, edge replication is a feature that we killed. Multi-database schemas, which was the ability to change the schema from many databases at a time, is a feature that we killed. And a couple of others. So if you're curious, go read the blog post. We said we are deprecating all of those features. We're not going to maintain our offering on Fly.io anymore. We're going to be moving all of it to AWS. And our original plan was to keep both clouds, but we said we don't have the bandwidth to do this. We're going to have to focus, and that's going to be the focus. This is what it means to you. If you are happy, like we're not going to be making general improvements anymore. Some of them, of course, we do. If things are broken, we'll fix it. Like we don't have a roadmap anymore of like improving things in a meaningful way for a long time. If you're happy, if the Turso Cloud is and then obviously we started referring to it as the Turso Cloud because we knew at the time that we were going to make the change. If it's good for you, if it solves your problem, great. If you think it would solve my problem if only you would do this other thing, I'm sorry, that's not going to get done for a long time. At some point we will. But our new engineering effort is going to go massively into rewriting SQLite. And again, we believe we're going to be better off at the other end of this because then we're going to be able to fix the write throughput issue. We're going to be able to fix the schema changes issue. And we're going to end up, when those things converge, with a much better offering on the other side, even for the people still using the Turso Cloud. But again, we were very explicit about it. We said this company is now going all in. We are a venture-backed company, so we're putting our financial stability at risk. We do not want to do this. What we did was we let go a lot of people, and we let go exactly of the people who will be working on the Turso Cloud. We were people working in marketing functions, right? People working in back-end functions, people working in front-end functions. So we said all of those people are gone. That gave us plenty of time. So we had at the time like more than 2 years of cash to execute this vision because we want to make sure that the company was still financially robust, which it is. Mm-hmm. The Turso Cloud today brings in more money than it costs, right? So it's a great place to be. And even after all those changes, we had of course a couple of churn, but even especially because our AWS software is so much more efficient to run, the Turso Cloud brings in more money than it costs. So we can put all of our new engineering efforts into rewriting SQLite, and that's what we're doing today.
Okay, so there's a lot there. I want to dig in on that turning point of you got to 1,000 stars and then jumped to 8. 6,000 and jumped to 64 contributors. So I'm of two minds about this. One is that is like incredibly good signal for an open source project, and 99% of them never get there, and so this is a signal of something.
Yes.
Right. I guess that's the one mind. The other mind is that is not the business signal. Maybe it's a corollary to the business signal, or like a parallel signal, something that tracks with it. But that's not the business signal, right? So from a business perspective, you're looking at, hey, we're going to do this open source project. We're getting a ton of people in. That's really great. What does that signal tell you about the business side? So you're receiving signal from an open source project. How are you translating that and applying that to a business side such that you look at it and you say, I'm willing to not blow up, but fundamentally change the business because I'm getting this parallel signal from this open source project. What did that tell you?
Yeah. So the what it tells us, and I had, as I mentioned, I had that in my mind already. With libSQL, we wanted to create this, and I mentioned that many times. I'm just going to do it again, just in case somebody started listening now. But we wanted to create this open contribution version of SQLite. It was the open contribution fork of SQLite. Now, we did that for a reason. And the reason for that is that we believe that if we could do this, and if we could start to see people using libSQL instead of SQLite, this is a tremendous business signal, because you now have people, most companies that have some open source presence, what they want to see is a tremendous distribution in the open source, and then you want to convert some of the distribution to a monetized offering in some way. You're never going to convert everybody, but you want to have those numbers, right? And with SQLite, I'm actually willing to have lower conversion numbers just because the install base is so huge. Like, there are trillions of SQLite databases. So I'm okay having less than 1% of that converting to business in some way. But so the business signal there is that if you can replace SQLite with your offering, just the size of the community that you can have is the biggest community in the world. And we wanted to do this with libSQL. That was part of our goal, right? If you remember, very explicitly we said, and again, we knew that to do this, it had to be not just better, but it should attract, it should give people who are using this a seat at the table. That's the thing that we wanted to do differently. And with libSQL, that did not happen, right? So with Turso, at the time being called the Limbo project, it happened immediately out of the bat. And then I started, and so it wasn't so much that this gave us a new business signal, but it reignited the business signal that the business thesis that we had before, but we had given up on. So when you look at the story of libSQL, and I wrote, all of that is public. I wrote it in the blog post. libSQL was this thing that we shot. Were we unhappy with the results of libSQL? No. We are now in hindsight, but at the time it was that story about, shoot for the stars that you might hit the moon. We're like, oh, we got a moon landing with libSQL, pretty awesome. We were able to build this cloud service and etc. But we were shooting for the stars. We didn't hit it. We got to the moon and pretty good place to be. But with the rewrite, we saw, oh man, the dream of reaching the stars, it's still here. So it just reignited the thesis that we had, that if you manage to replace the most in an organic open source way, and to do that, we know that we have to be aggressively open source. We are actually more open source than SQLite. Right, and I'm happy to go into more details as to why I claim that. But what we want to give people now is a open source, open contribution version of SQLite that you can use instead of SQLite for anything you want, detached from our cloud business. We don't want to bring people necessarily to the cloud business anymore, right? We want this to, we want every device in the world to be running Turso. We want every robot in the world to be running Turso instead of SQLite. We want every manufacturing facility in the world to be running Turso. We want databases everywhere. That's what we want to do. And we knew back then that if we managed to do this with libSQL, this would be a home run. It just didn't happen. And we saw this happening. So it wasn't a new signal. It was just like a signal that we now could execute on the thesis that we had and had to adapt in the past, right? So that was essentially what was behind it.
So this is interesting because from like an outside or maybe naive perspective, it looks like, whoa, Turso the company has just taken a left turn. But this is a fulfillment of the original vision.
Of the original vision.
So
yes.
The original vision was, let's make SQLite open contribution. And the vehicle by which you did that was libSQL. You found a lot of success, but not the success you were looking for. And so the original thesis was, let's make a new SQLite, get a ton of distribution, and some small portion of that value will flow to Turso Cloud.
Turso Cloud, yes.
And that, that worked on some level, but you plateaued in terms of what you, and more importantly, what the outside contributors can do, right?
Yeah.
Because an outside contributor comes in and says like, "Holy crap, I can't touch this. This is SQLite internal dark magic. I am not touching that." And so you plateaued out on the original. I
just want to clarify that it wasn't the business plateau. Like Turso Cloud was still growing, yes. Right? But the vision of replacing the SQLite plateau.
The vision of let's basically change the SQLite world. It ran up against a wall, which was SQLite itself, and so now this is not a fundamental vision change. This is just, let's try another vehicle by which we can fulfill this original vision. Yeah. And so that helps me understand why something that seems like nominal or like interesting but not that important, GitHub stars. Yeah. That's why that now to me seems like, oh, okay, I get it. Like,
but that was not even the strongest signal, because the strongest signal we had was the number of contributors, because
the number of contributors.
That's the thing that
The business thesis has always been, if we can grow this contributor base, community, whatever, we can scale out this SQLite rewrite, and then we can hit a massive amount of distribution, and some portion falls to the bottom line of Turso Cloud. So that whole story makes a lot of sense to me now. So I guess my question is, SQLite, famous, like super famous for being rock solid, right? You and Pekka and the team are taking on a rewrite of maybe one of the most stable pieces of technology to have ever existed. And you're doing it without the proprietary test suite. And so what are you all thinking about in terms of how can we convince not only the outside world, how can we convince ourselves that this is as stable as it deserves to be, and as the reputation of SQLite is? How that's going to take years for you to get there in terms of reputation, but technically, how are you even going to get close to stability when you don't have that test suite?
For me, this is the funniest part, and sometimes call it whatever you want. I know what we would call, but like destiny or the universe or etc. I'll leave it open to the audience, but providence. But this is for me the most amazing part of this whole story, because there is one thing that we have today that enables us to do this. Okay. And that thing is not something that we had when we started libSQL. So when we talk in terms of, it's funny because when I think about it and look back at it, and were we wrong? Were we right? Should we have rewritten this to begin with? Because that's what we wanted to do, right? But one of the reasons we didn't rewrite was exactly this. I mean, with even with the challenges that you have in touching the core, man, SQLite has it's going to take us years and years and years and years and years to get to that level of stability. And our mind at the time was like, how do we get to that level of stability? You have to write a ton of tests. You have to essentially redo what SQLite has done. And it's going to, in our estimation, it's going to take 3 years, it's going to take 4 years, and it's not worth it. Let's fork it instead. So that was the thing that was behind the fork, right? And ever since, Pekka and I became acquainted with a testing technique that we used internally in our server. And again, it's not that didn't exist at the time. It just wasn't on our radar. It was just not something that we were incredibly familiar with. But through looking at the industry and looking at other developments, and I will call out here Tiger Beetle. Tiger Beetle is probably, what I used to say is that even though I run a database company, Tiger Beetle is the database company that I appreciate the most because they're the craziest guys out there doing like something incredibly insane, which felt weird because I should feel like that about my own company. Now I can say, now I'm in the point that I run a database company, which is what I believe the craziest pet, the nicest database company. And in fact, the CEO of Tiger Beetle became an investor. Nice. Which I hope it means we just disagree on that. Obviously for me his company comes in a close second, and as the nicest database company out there. And I would hope that for him is just the reverse. Like Tiger Beetle is the best, and the Turso comes as a close second. But they were using a testing technique called deterministic simulation testing. And if you think about the way software is traditionally tested, it's just like this. You have to write a F ton of tests. You have to write 5 times more tests than you write code if you want this level of reliability. Deterministic simulation testing is slightly different. You don't write unit tests, right? Okay. So if you think about how would you test? Let's think about an example. I am trying to test my select queries, and I want to make sure that every time I run from I read from the database, I read the correct value. What you do is you try to come up, you write the database file, and then you run select star where something, and you match to see if the value is what you expected, and then that's your unit test. And then you think, but if you're writing at the same time that you're reading, you're going to have a problem. Then you write another unit test in which you are writing it at the same time that you're reading, and then you read. Okay, but if you have an index, that's yet another corner case, and then you write another test to cover this corner case, right? What you do with deterministic simulation testing is that you don't write tests like that. You write a fuzzer, which is a component that's going to generate a large amount of random tests in a specific space. So of course, this is not magic. You have to write this in to explore a particular part of the space of possibilities. But once you define those boundaries, like you could have indexes like, between indexes in either none or all columns, and then pairings, random pairings of columns. And then insert statements with this level of complexity and select statements with this level of complexity. So you write essentially a test generator, and then this test generator will generate a lot of tests, and then your I/O subsystem and the project has to be written with that in mind. It's something that is very hard to bolt on. So your internal I/O subsystem will inject random failures, right? So, for example, Turso has an I/O subsystem that does I/O, but during the simulation, you don't run the I/O subsystem. You replace it with the simulated I/O. So you will be injecting failures all the time with a random probability. All of that is randomized, but it is deterministic. So it is using a pseudo random generator, and if something fails, and if you pass a seed, you have the exact sequence of events that led to things. So debugging this is trivial. And again, having written databases in the past, once you have a failure that is a serious failure that leads to incorrect results, that leads to a data corruption, like it takes you months to figure out what's going wrong, right? Because then you have to how did that came to be, and you come up with a thesis, and then you try to reproduce it, and then you never reproduce it. With deterministic simulation testing, the simulator is exploring a large part of the space of probabilities. What Joran always says is that we run centuries of execution in 10 hours, right? So you explore all of those crazy variants. And the way you test it is that you don't test anymore a single result, right? You test properties of the system. So it becomes, some people refer to that as property-based testing. For example, you do all of those inserts and etc. And then at the end, you run a integrity check of the database that makes sure that the B tree is in a good state. And if there was a data corruption, that integrity check will fail. Or for example, you run a bunch of selects, and then you sum them up, so it has to sum up to that number, right? Or like you're always verifying not the results of an individual operation, but you're verifying that the properties about the system hold, and then you let the fuzzer generate testing at will, and if the properties fail, you have the exact sequence of steps. So we were using this in the Turso Cloud, and we had those bugs that lead to data corruption. Data corruption happens in databases, and it's one of the scariest things that can happen because like your data is actually worse than gone. It's corrupted. it's incorrect, right? But it happens, and hopefully not often, but it's the scariest thing in a database company. And we had those issues in which a data corruption happened, and 6 hours later we had a fix. Right, because those issues happen because the simulator did not explore some part of the space of possibilities well enough. And then what you do is instead of thinking what was the exact sequence of events that led to this bug, your thinking becomes what was the general conditions that could be present at this time that are not present in the simulator today. And then you add them to the simulator, and lo and behold, the bugs show up, right? So what you're doing is that if a bug is found, instead of spending months debugging this, you spend hours improving the simulator so that the simulator finds the issues for you. Most of the time, you find those issues, and then the bug, understanding why that happened becomes trivial because you have the exact sequence, the deterministic. You just run the simulator again with the same seed, and then you can have the exact sequence of events that led to that. So it's a testing methodology that is fantastic, is revolutionary. We're not the inventors of it, but we became acquainted with how Tiger Beetle, for those who don't know, is a database that is trying to rewrite the financial backbone of the financial industry. They want to be a database for Visa, for Master.
Admire them. That's
so they had this issue. Say, how do we prove to banks that our stuff is going to work better than their bespoke systems running for 50 years? And the way they did it was deterministic simulation testing, and they managed to do it. And they were like, "Hold on, let's do it." And then we started doing this in the Turso Cloud. We rewrote large parts of our Turso Cloud server infrastructure to use deterministic simulation testing, and the results were awesome. So when Pekka started thinking about maybe we should rewrite, what if, when Pekka was having this vision of like, what if, we now had the missing part of the puzzle. The way we do this is with deterministic simulation testing from the start. So if you look at the first commits to this project, it was essentially not a database. It was a simulator of a database. And then you start adding those things. Now write a query engine and expand the simulator to generate those queries. Now the simulator doesn't catch any problems because if you're not writing to the database, there's very little that you can do wrong, but at least the simulator is there. Okay, so now we're going to implement support for inserts. Okay, now you simulate, and now you improve the simulator to generate those inserts, and now it starts catching a couple of issues, and then you go from there. So what happened between between December and now that we decided, okay, now it's the time that we renamed this to Turso? Because if you go back to what I said we wanted to do this from the start because that was the lesson that we had from libSQL. Keeping both names doesn't do as much what we want to do in terms of benefits, but it has a huge cost. So how do, we were afraid that, you download Turso. Okay, so now it's a single brand. You download Turso, but nothing works, and it's full of bugs. And so, is it really helping you? No.
Yeah, no.
So what happened now that we were comfortable just saying, okay, now let's release Turso Alpha, is that our simulator doesn't catch any more bugs. So we got to the point, and by the way, we do 2 layers of deterministic simulation testing. We use our own simulator, and we also use a tool called Antithesis, which is a deterministic hypervisor that does that for you. So it's another, it's something for way more complex. But I'm a super fan of what they're doing. They are our partners on this. So we do 2 layers of testing. And both Antithesis, our external simulator, and Antithesis can do things that our simulator can't, right? But by the nature of their design, and our simulator themselves, I mean, both of those components were not catching any bugs. And then what we decided is, okay, now this is stable enough that we can. Now it doesn't. There are many things it does not support.
Sure. Yeah.
It doesn't do indexes, for example, which is one of the things that we're doing now. If you go to the compat.md file, there's still a lot that is not there. But again, and let me hedge here. It's not that very bad bugs do not happen. Is that it happens way less than it would at any open source project at this level of maturity. Because again, the simulator is not magic. The simulator is still software, and it has to explore. But what we found is that like we're exploring a pretty large and relevant part of the space of possibilities, and the bugs are not there. So Turso works. And because we're so confident that Turso works, but at the same time we are this alpha stage, we came up with this challenge in partnership with Algora, that if you go to turso.algora.io, you're going to see our challenge there. If you find any bug on Turso, not Turso Cloud, Turso Cloud is a separate thing. If you find any bug on Turso, the database that leads to a data corruption, we're going to pay you $1,000. With the caveat, I mean, it's not just reporting the bug. You have to improve the simulator so that it catches your bug. And then the instructions are all there. But like if you do that, we give you $800, and if you fix the bug on top of that, we give you another $200 for a total of $1,000. Those can go to separate people, right? You can just report if you want. But we're paying $1,000 per bug that improves the simulator, because we know that like once the simulator gets improved, bugs in that area never happen anymore, right? And $1,000 is not a lot of money, but I still think it's a substantial amount of money for a project that exists for less than a year. But our goal is to actually get that to 6 figures. So I want to get to the point, and I think we will be confident with the deterministic simulation testing that maybe 2 years, 3 years down the road, we're going to be paying you $100,000 if you find any bug and improve the simulator to catch that bug. But again, in the alpha stage, things we know the bugs are so we're not claiming that our simulator caught all bugs that exist. We're claiming that there's a large part of there's a large amount of bugs that they're just not there. We focus a lot our simulating efforts in data corruption. We have not focused our efforts in correctness, so we're not paying you anything for correctness. But if you download Turso today, you're going to see a claim: do not use this in production. It's alpha. But then again, as it evolves, we want to increase the scope, and we're going to be paying you the money for ACID violations, correctness issues, incorrect queries, and all of that, and corruption. And we're going to be paying hopefully before the end of this year. Hopefully, I want to get that to $5,000, and then hopefully next year we can get that to $10,000. And the next stage will be getting that to $100,000. So we will get to that point. Again, I think we're not there yet. But the deterministic simulation testing framework is what allows us to do. And we actually believe we're going to end up in even more reliable stage in SQLite, because it's just, seeing the success of Tiger Beetle, that's what it does. It explores a large, you don't have to write those tests, you just explore. And it's been fantastic. We've been incredibly happy with that. I don't think we could have had without this, getting to the point that we're comfortable paying people $1,000 per a certain class of bugs in 6 months of development. That would not have been possible. And with deterministic simulation testing, we're comfortable doing this.
So I want to dive into a few points, but first, has anyone claimed $1,000 yet?
No, I am
Okay.
100% sure that one person will, because like one of the things that happened is that when one of those 64 contributors that show up and are still there with us today is a guy that's been doing his PhD in deterministic simulation testing. So that's why he actually got so interested in the project. And he's a Turkish guy doing his PhD here in America in the University of Maryland, if I'm not mistaken, Alp. And he is a freaking beast. So he's actually one of the reasons why we got to this point so soon, because he came into the simulator and said, man, so he messaged me the other day, said, Glauber, just to be clear,
Am I eligible?
Am I eligible? I said, yeah, you are. In fact, we would love to, he doesn't work for Turso, and we would love to, just give something back to him in some way. So I actually, Alp, if you're hearing, we decided already that even if you don't find anything, we'll find a way to get you the prize. I mean, we're gonna pay retroactively for something you found already. So we wanna of course, if to the extent possible, reward the amazing work that Alp has done. We would not be here without him. It just goes to show the power of open source. He has his own motivations, which is to do his PhD thesis. We have ours, but through this open contribution community, you can get those two different sets of interests working together. That's why an open contribution community with the high bar that comes from the deterministic simulation testing. No code goes into Turso that doesn't pass deterministic simulation testing. So the bar is there, right? I am sure Alp's going to find something. I am 100% sure that Alp's going to find something new. And if he doesn't, we'll pay him anyway. So I'm sure that at least one prize is going to be paid. And we're fully expecting some others. I think the number. I think if you fast forward 6 months, Pekka and I are estimating that we're gonna be paying between 5 to 10, hopefully, of because it's alpha. And at that point, we're gonna be comfortable bumping. If we end up paying more than that, I think we're gonna take a step back and give it more time. I actually think we're gonna do less than that. I told Alp only Alp, just don't bankrupt us, man. Because but I'm sure we're gonna pay. I'm sure we're gonna pay some. It has not happened yet, even though Alp's been trying. So he has not yet found. We released that 10 days ago from the time that we're recording. I'm sure he'll find something. It hasn't happened yet, and I'm sure somebody else will find a couple as well. Again, it's consistent with our idea of the state of the simulator today, which is pretty good, but there's still a lot to do. There's still some crazy combinations that we believe will yield bugs. But it hasn't, in 10 days, it hasn't happened yet.
Cool. Love that. He's definitely going to find one. He may sit on it until the prize goes up to 100,000, but he's going to find something. As we're wrapping up here, I want to just dive into a few of these deterministic simulation things. This sounds incredible. So if I can dumb it down just a little and see if I'm still directionally correct, this deterministic simulation testing, let's imagine we've got a function that accepts, 2 arguments, right? And we can, as the people who are writing, writing the simulator boundaries or test case for the simulator, we can say function this parameter A should accept numbers between 0 and 10. Mm-hmm. And parameter B should accept a string up to 30 characters long. Mm-hmm. And then the simulator is going to say, okay, 0 to 10, huh? What if I pass potato? What if I pass infinity? What if I pass 11? And it's going to do that, but it's going to not only do that, it's going to do that with both arguments, and it's going to do an exhaustive in boundary, out of boundary test, cross
Yeah.
testing these both arguments together. And then let's say we pass a seed of, 1, 2, 3, 4, and we pass this seed and it runs a million tests and fails on one. We can pass that seed again and it's going to run the exact same million tests such that we can run it over and over and over until we fix that particular bug. So it's testing presumably everything within the bounds and then all kinds of stuff outside of the bounds, including numbers that are slightly over, but also different data types, failures to the disk, all of that kind of stuff. Is that, is that directionally correct?
Directionally correct. So keeping within this framework, the way to make it fully correct is the following. So first, you're not going to explore all possibilities just because it's computationally prohibitive. So you're going to randomize the possibilities, right? So again, you decide I want to run this for this long, and then it's going to keep randomizing. Then the other thing that needs to happen is that every time, and this is the part that's just missing. So the thing that was corrected from what you said is that it's not going to explore everything because you can't. Imagine if that had 10 parameters and those 10 parameters can so it's going to randomize the inputs. And the part that's missing is that for this to work, every time your function does something that does I/O, that I/O has to be replaced with this, because what you described so far is a fuzzer, right? Which is part of how this works, right?
Got it.
So the fuzzer just is the component that generates all of these inputs randomly. What the simulator is going to do is that the simulator is going to replace all the I/O that is done in your system by a simulated version of the I/O. So
I/O.
Yeah, and that is what allows you, because you're not going to run all the tests, right? It's not, you run all the tests again, because if you run that test again and then you do I/O in a different way, it might not fail. And if you fail, it may fail in a different way. So you're not going to run all the tests until that point of the one that failed. You're going to run just the test that failed now, right? Because imagine running all the tests again can take 10 hours. So you're going to run just the test that failed. But with the seed, you know all the I/O that was generated, right? So imagine like if you're doing this just for a function, and that function is calling a endpoint on an API. You're not going to call the endpoint on the API. You're going to put the simulator there to generate responses randomly, that's the hard part. The responses have to be randomized, but they have to make sense, because you can't write something to disk and then later respond with something else, right? It has to behave like your system would, but fail in interesting, because the randomizer is also randomizing the failures in the I/O system, right? Mm-hmm. So let's say one time you call into this API to respond with 35. You're not going to respond with 32 later when you get it again, because it wouldn't be what the system does. But you might fail to respond at all in certain connections. You may, if you're expecting a JSON payload, you might have this payload truncated. So you start injecting those random failures. But every time you do I/O, you no longer do I/O through your real I/O system. Every time you do, and I/O here means everything that is non-deterministic, right? Mm-hmm. So everything that is non-deterministic, like grabbing a timestamp, has to go through the simulator. Talking to, in our case, the storage device has to go to the simulator. Generating random numbers has to go through the simulator. So everything that you do that would have side effects in the system has to go through the simulator, so that when you run that one test out of a trillion that failed, that test will reproduce exactly, right? And then the fuzzer is the component that is generating the inputs in different ways.
So what I described was testing the boundaries of a function.
What you described was the fuzzer. Yes, you described the fuzzer, which is a part of this. Yeah.
So testing the boundaries of that function is the fuzzer. The deterministic simulation testing is testing the boundaries of the system.
Yeah.
The places where it reaches out and grabs other stuff. It's saying, read through me, through the simulator, and the simulator will return deterministically normal, totally good results, or oops, the disk isn't there. Oops, the power went out, the network is down, whatever. That Makes a lot of sense. Okay,
And
so
again, more than that, even if the simulator, because the early days of our simulator, we did not have fault injection, right? So I don't want to make it clear, seem that it's necessary. Even if you don't do fault injection, which is right, you need that component to make sure that every time you do I/O, the same thing happens, right? Because if you're just running this function, imagine that there are those famous bugs that like some people joke about it. The bug only happens on a Sunday,
of
right?
course, yeah.
So even if you read a timestamp, every time that test reads a timestamp with that seed, it needs to read the same timestamp to the microsecond, because you need to be able to reproduce that bug. So everything that will make a run be different than another run has to go through the simulator, even if you don't inject any faults, right? Because you need to make sure that if you run that test again, you can deterministically reproduce everything that happened. But once you have this beautiful thing that is virtualizing all of your I/O, it's yet another boundary where you can inject some randomness there as well.
Oh, this is cool. I love this. I'm gonna have to do
Yes.
some reading on that. That sounds super awesome. So, as we wrap here, tell us what the next, 6 maybe too far. Tell us what the next 3 months hold for Turso Cloud, and how can people get involved in what sounds like an incredibly interesting project.
People who are a lot of our early contributors claim, and we talked to all of them, by the way, when I was in this process of like, what do I do with this? I wanted to reach out to those people and talk and understand if the signal was real or it was just like a bunch of people randomly showing up. And what a lot of them said is that, man, I love the space, I love databases, and you go contribute to a mature database. It's hard to even find what you contribute, but in this project, I mean, there's so much to do. And this is a window of opportunity that is not going to be there forever. So I strongly recommend people in the audience, if you're curious about how databases work, if you want to contribute to a database where you have opportunities to write a query planner, like something that is from scratch. The query planner itself wouldn't be from scratch because Use is already doing it. But go look at the compat matrix. There's just so much. There's so much to do, right? Even though we're progressing fast, I suppose that in the next 6 months we're still going to have this window of opportunity for people who like databases, who like system programming, to really contribute in a meaningful way to a very interesting system. So there's going to be a lot of that. We are going to be now. We believe we support around 50% of what SQLite supports today. We want to get to a beta where we're supporting around 80% in 3 months. And one of the major things that we're going to be doing is supports for indexes. So, for example, indexes are there in the code, but disabled by default. So bugs, by the way, if you find bugs in indexing that leads to data corruption, they do not count for the challenge because it's a feature that is, we haven't blessed yet, right? So we want, but it's coming. So we want, I think in another month or two, we're going to support indexes. And now with indexes, a lot of those production use cases can be unlocked, right? So because without indexes, the database is, Aaron, you've done a lot of database education. Every time somebody has a performance problem, what's the first thing you look at? Always indexes, right? So the moment you support indexes, they start to become a more serious contender for some workloads. And we want to get the overall support to 80%. We also want to support at least one major feature that SQLite does not support, because again, if you just support 80% of SQLite, it's not there yet, right?
Point? Yeah.
What's the point? And we want to give people a reason to use Turso sooner rather than later. So in parallel with that, we're also going to be, and there are 3 things that we're working on right now. Let's see, we believe at least one will be for the beta in good shape enough that will become a major feature. One of them is just concurrent writes, which is, on the one hand, is everything that people complain about SQLite. 80% of the complaints are around concurrent writes. So we're working on that already. It is also a very hard thing to do. So will it be ready in 3 months? We do not know, but we're actively working on it. The second thing is better schema changes. And better schema changes also mean more performance schema changes because SQLite is very slow with schema changes today. We want to make it better, and we want to make it more capable. It's also very hard, so we don't know exactly where we're going to be at that point. The third one is it's actually simpler. So that is the one that I'm betting that we're going to have for sure in 3 months, which is CDC. Something that a lot of people also ask for in the Turso Cloud. How do we get access to what changed in SQLite since a moment in the past? That is actually already merged to the tree. And we're going to have a release, hopefully having CGC in a couple of days. At which point, if you find the data corruption in CGC, you can get $1,000, right? So those three things are things that we're working on. The SQLite does not have. So we want to have at least one of them in a very good very good shape. CGC will take a couple of months still to stabilize, right? And around 80% of SQLite does. And at that point, we're going to call it beta, and then we're going to go from there.
Wow. Exciting times. I like this. I like this roadmap. So if y'all are listening and you want to get in on the ground floor of a database right now is your time to get over there and put into practice maybe some of the stuff theoretically. It sounds like a lot of fun. Tell the people where they can find you and how they can reach out.
So how to find me, if you want to find me physically, I am in Richardson, Texas.
Yeah, right down the street from me. You can find us both.
It's 15 minutes away from Aaron. So if you are in the area and would love to talk databases, if you have use cases for SQLite, I'm of course even more incentivized to do so. We'd love to meet. On X, I am GLCST, just most of the consonants in Glauber Costa. So GLCST is my handle. I'm on LinkedIn as well, and I am on the Turso Discord, which is tur.so, Turso/Discord. So you can join our Discord there. And always I'm always happy to chat with everyone. I'm a very active person on our Discord now, a little bit less than before, just due to the personal circumstances of my life. But I'm very active on our Discord as well. So always happy to chat with people there.
Awesome. Well, this has been fun.
And of course, github.com/Turso database/Turso, which is Turso, the embedded database.
Perfect. I'll leave links to all of that down below. And if y'all are listening on audio, there's a YouTube channel, and if you're listening on YouTube, there is an RSS audio channel if you want to throw it in your podcatcher. Glauber, thank you for doing this. I'm sure that I will see you soon. We have to tell the listeners that your wife made incredible apple pies for us.
Oh yeah,
and so
she's a chef. You will notice that I have all sorts of books here in my background. A lot of them are bakery books because my wife actually went to the Cordon Bleu in Paris.
Oh wow!
And I gained a lot of weight since then. I'm always on a struggle. She bakes all sorts of amazing things. A lot less now, but she's just the best.
Y'all came over for all the kids to hang out, and she walked in with these 2 apple pies, and apple pie is my favorite. And I kid you not, this is not flattery, best apple pies I've ever had.
And homemade ice cream as well. Yeah.
Oh, dude, the best. So whenever new Bebe comes, we'll come over with a bunch of food and feed y'all
awesome,
in return.
Man.
But thank you for doing this. Thank y'all for listening, and we will see you next time. Bye.